Okay class, Assalamualaikum. So today we are going to learn how to interpret distance time graph. Okay, so here we have two diagrams, diagram 1 and diagram 2. So for the diagram 1, we can see that the line is going up, and for the diagram 2, the line at first going up and then go flat and then going down. Okay, so from these two graphs, we can see that it has several gradients. Okay, so gradient is the vertical distance over horizontal distance. Okay, so for the first diagram, okay, look at the first diagram. Line OA, it has a positive gradient. Okay, OA, it has a positive gradient. Line BC also has the positive gradient. For diagram 2, line OP, it has positive gradient. Okay, so when is the gradient become negative? When the line is going down. For example, line QR. Okay, when is the gradient become 0? When the line is flat, like line AB and line PQ. Okay, enough talking about the gradient. So we know what the gradients are. We know what does it mean by positive gradient, negative gradient, and zero gradient. Okay, next we want to talk about the zero gradient further. Okay, as for line AB here, line AB, okay, line AB here, it has zero gradient, meaning there is no change in distance. Can you see that the distance stay at S1 from time T1 to time T2? Okay, within this period the distance is the same, so meaning the zero gradient means no change in distance, means the motion stops. Okay, so it's the same goes to line PQ here. Okay, along the line PQ, the distance from the origin is always S meters. As here, the distance doesn't change even though the time increases from T1 to T2. Okay, so next we want to talk about the motion. Okay, so for the first diagram, from location O to location C, okay, wait, from location O to location C, what can we say? The motion of S meters in a period of T seconds. Okay, the motion of S meters for the period of T seconds. Okay, how do we interpret the diagram 2? We would say the motion of 2S meters. Motion of 2S meters. Okay, where is it? Oh, it doesn't work. It doesn't work. Sorry for that. Okay, the motion of 2S meter. Why is it 2S meters? Because when you go up here, you have move for S meters, and then when you're going down here, and then you move for another S meters. So that's why I said the motion of 2S meters. Okay, 2S meters in a period of T seconds. Okay, in a period of T seconds. Okay, so next let's look at another one. Here we have example 4 from the textbook. Okay, the distance time graph shows the motion of a car and a tour bus. Okay, car is the pink line, the tour bus is the green line. Okay, graph OA represents the motion of the car from Puchong to Malacca. Graph BC represents the motion of the tour bus from Malacca to Puchong. Determine the difference in speed in kilometer per hour of the two vehicles. It's very easy. So let's do the calculation here. The difference in speed, meaning we have to determine both speeds. Okay, calculate the speed for the car first. Speed of car equals to difference in distance over difference in time. Okay, remember, speed equals to distance over time. Okay, so back to our working solution. So difference in distance for car is 150 minus 0, and then the difference in time is 2 minus 0. Okay, final time minus initial time. Okay, so we have 150 over 2 equals to 75. The unit is kilometer per hour, of course. Why is it kilometer per hour? Because our distance here is in kilometer and our time here is in hour. Okay, so we have 75 kilometer per hour for the car. How about the speed of the tour bus? Speed of tour bus. Okay, the tour bus speed equals to initial final 0 minus initial 150 over final 3 hours minus 0, here hour, here kilometer. So we have negative 150 over 3 equals to negative 50 kilometer per hour. And then when we talk about speed, if we see the negative sign in front of the figure here, the negative sign here, it means that the tour bus and the car move in the opposite direction. So just for you to remember, the speed is actually only 50 kilometer. We don't say that the speed is negative 50 kilometer per hour. The speed is 50 kilometer per hour. Okay, the negative sign means that these two, they go in opposite direction. Okay, so the difference in speed equals to 75 minus 50 kilometer per hour, 25, right? 25 kilometer per hour. So that's the answer, 25 kilometer per hour. Okay, so let's move to next example. Next example here. Okay, example 5 from the textbook again. So the distance time graph shows the motion of a car for a period of 4.5 hours. Determine the duration when the car is stationary. Stationary means the period that the car stops. Okay, then determine the speed of the car in the first hour. Okay, the first hour. And last one, describe the motion. Okay, later we're going to describe the motion. Okay, first let's find the duration when the car is stationary. Okay, look at the graph. Okay, let's switch to the working. So stationary means the period where the car stops. Okay, it stopped from 2 to 3. Stationary meaning car stops. Okay, stops means distance doesn't change. Okay, so for how many hours? For 1 hour. Okay, from 3 to 2 hour. So equal to 1 hour only. Okay, next, the speed of the car in the first hour. Okay, when we talk about speed, meaning we are talking about the gradient of the straight line. Okay, the gradient meaning the difference in distance divided by the difference in time. Okay, difference in distance divided by the difference in time. Okay, so the distance, the first hour. Okay, when we look at the graph just now, okay, in the first hour here, we don't really have the exact point. What we do have is the gradient for the first 2 hours. And don't forget, the gradient for the first hour or for the first 2 hours, they are both the same because they are on the same straight line. When they are on the same straight line, along that straight line, the gradient is the same. So when the question asks you to find the speed for the first hour, you can just use the gradient for the first 2 hours. It will be the same. Okay, don't worry. So the first 2 hours, 150 minus 0 divided by 2 minus 0. Okay, so 150 equals to 75 kilometer per hour. Okay, so the gradient or the speed is 75 kilometer per hour. Okay, so we are done. Next, question B. Describe the motion. Okay, how do we describe the motion? First, we talk about the speed of the car. What can we say about the speed of the car? The speed of the car for the last 90 minutes. The last 90 minutes, we have another straight line going up from 3 hour to 5 hour. Okay, so the last 90 minutes, from 3 to 4.5. So the speed equals to, for the distance first, the final distance is 270 minus the initial at 3, 150. This one in kilometer over the 4.5 minus 3, of course. Okay, so use your calculator. 80 kilometer per hour. So the speed is 80 kilometer per hour in the last 90 minutes. Okay, class? Here, in the last 90 minutes. Okay, so how do we say about the motion? So the car travels for 120 kilometer. You want me to write? The car travels for the distance 120 kilometer with a speed of 80 kilometer per hour in the last 90 minutes. Okay, remember the questions only ask you about the last 90 minutes. Okay, the last 90 minutes. So you talk about the distance 120 kilometer and then the speed 80 kilometer per hour. Okay, so we are done with example 5. Okay, the last thing is to look at the textbook again. the textbook again. Where is it? Okay, let's stop first, and then I'll try to get some more information from the textbook. Okay guys, thank you.